So just looking at an alternative approach to what we've just done. So for any polynomial p of x, if p of a equals p of b, then its graph will have at least one turning point between x equals a and x equals b. So if we have p of a equals p of b, then we can say we'll have at least one turning point between x equals a and x equals b. So somewhere between those. So in this example that I did just earlier, so we've got a maximum turning point must lie between the x values for which y equals positive 8. Okay, so just as a rough sketch, we had something that looks like that. Okay, we knew that this is 8, so drawing a straight line, it must be for values for which y is x values for which y equals 8. So if we substitute y equals 8 into the equation, so here's the equation. Now if y is equal to 8, okay, I'm going to expand that out. We'll get x cubed, take 3x squared, take 6x plus 8. Okay, and that's all equal to 8. Now I can take 8 on the other side, so take 8, take 8. We'll get 0 equals x cubed, take 3x squared, take 6x. Take a factor of x out, we'll be left with x squared, take 3x, take 6. So then we can solve and say x equals 0, or x squared, take 3x, take 6 equals 0, and solving that. So as the cubic graph must have a maximum turning point, the quadratic equation must have a solution. Solving it would give the negative solution as x equals minus 1.37. Rather than test values between x equals minus 2 and x equals 1, as we have previously, the starting interval for testing values could be narrowed between negative 1.37 and x equals 0. So what does that mean? Well, what I've done was minus 1.37 was that point there, and we know this point here at 0. So we know the turning point must lie between these 2 points now, instead of trying between 2 and 1, which was quite larger. So your table of values, we've just decreased, I guess, in a way. So we try smaller numbers, or a bit more quicker. So that's just an alternative approach. So we'll go into an example, example 10. So example 10, state an interval in which the x-coordinate of the minimum turning point on the graph y equals x, x take 2, x plus 3 must lie. Okay, so the x-intercepts, we can say straight away, is x equals 0, x equals 2, or x equals minus 3. Really handy when it's in turning point intercept form like that. So if we put them in increasing order, so it'll be minus 3, 0, 2. So the graph is a positive cubic. Positive, 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 so it has to be positive cubic. So the first turning point is going to be a maximum like our example that I did before, and the second one is going to be minimum. The minimum turning point must lie between x equals 0 and x equals 2. So we'll look at the minimum value this time. So again, make your table of values. So you have x and y. Now we said it's between 0 and 2. Oops. So between 0 and 2, and put in the numbers for your equation. So at 0, we're going to get 0. At 0.5, sorry, put that into that. We'll get negative 2.625. At 1, we'll get minus 4. At 1.5, we'll get 3.375. And at 2, we'll get 0. Okay, so from our table of values, we can say the turning point is near 1, negative 4. Okay, remember we're looking for the minimum this time, not the maximum. So if we're looking for the minimum, we want the lowest number, smallest number here. So it's around 1. So if we zoom in even closer to 1, so 1, and we'll say 0.75 and 1.25 either side. So x and y. Okay, I'd get some numbers. Putting in your calculator. So in your calculator, at 0.75, you'll get minus 3.52. At 1, we'll get minus 4. That hasn't changed. And minus 3.98. So it hasn't really increased. Because our maximum value is still 4. So if we go in even further, let's try 0.1 either side. So 0.9 and 1.1. Okay, so same thing, put them in your calculator, x and y, so 1 won't change, but at 1.1 we should get minus 4.059. At 0.9 we'll get 0, so minus 3.861. Okay, so as we can see, we've actually got a higher number here. Okay, our first estimation was at 1. Sorry, at 1. Next one was at still 1, but now we've gone even further in. And so obviously the more smaller these numbers are, the more accurate we'll get. But again, that means more work. So we want to try and skip or estimate as close as we can without having to go too far. So what we can say is the minimum turning point is approximately 1.1 and minus 4.059. Okay, so without going too far in, that's a good estimation. So when we draw the graph, we'll have our turning point, minimum turning point at that one. And again, do the same thing for the maximum turning point. So that's chapter 5.4. Have a go at the questions. And that is the end of chapter 5 as well. So have a go at questions from 5.4, have a go at some of the review questions, and we'll be jumping into chapter 6 soon enough.